So maybe you found a question on a review sheet, maybe you found a question, I'm sorry, on something or other, yes.
On like the worksheet we did in class last period, we do 13.
13B. So that's the big review sheet, 3A to 312. And we're doing 13B, which is all, from 13B to 27 is now on video. Going to YouTube right now. So y equals, we're graphing y equals negative 2 cosecant 1/4 x. All right, so first thing I do, you don't have to do what I do, but I'm not very good with cosecants, so I'm going to think of this as a sine. So I'm going to graph the corresponding sine curve, because then I know what to do. Wherever I have zeros, I drop in asymptotes, and then I flip my hills and valleys to make parabolas. So, I'm doing my amplitude, I'm doing my sine curve, I should do it pink. I'm doing my sine curve. So the amplitude is 2. It's a negative sign, so it is going to start then. So there's my sine curve. Now, what does that do? Divides the, actually it blows it up because it divides the x's by a 4th, and dividing by a 4th is timesing by 4. So normally I would be ending at 2 pi, but now I'm going to be ending at 8 pi, and the midpoint will be 4, and then the midpoint of those will be 2 and 6. So there is my sine curve. Now I'm going to turn it into a cosecant by dropping in my asymptotes every time I have a 0. If the sine is 0, the cosecant is undefined, 1 over 0. And then I'll flip my curves. So the black thing is the answer to the question. Okay, Fred? All right, what else did anybody find? Again, that sheet's been videoed. The rest of this stuff hasn't, so hopefully you looked at some other stuff.
This isn't like a specific question, but when something says it's in standard resistance, does that mean that it's like assumed?
It means it's labeled exactly the way it is on the unit circle.
Okay.
So when you start on the unit circle, this is pi over 2, right? This is pi, this is 0. This is where we start. That's standard position.
Okay.
All of our angles are in standard position, except navigation isn't sometimes. On which homework? The 3.12 homework, number 7. Let's see if I have any. I have a couple of these I can turn back. So, let's all right, so alpha and beta are somewhere out there in the corner. And in fact, I think I'm told they're both in the interval from pi to 3 pi over 2, which means they're where? Where are alpha and cosine, so I'm here for alpha, and the cosine is negative 5/13 x over r, or adjacent over hypotenuse. And the sine of beta is negative 2/3. Again, opposite over hypotenuse, or y over r. I want to find the sine of alpha minus beta. What's my formula for the sine of alpha minus beta? Sine alpha cosine beta minus cosine alpha sine beta. So I need to figure out what these four numbers are. I know that the cosine of alpha is negative 5/13. They told me that in the problem. And I know the sine of beta is negative 2/3. They told me that in the problem. Now, how am I going to find these guys? What kind of triangles are these? They're not 45, 45, 90 triangles. They are right triangles though, right? They're right. And what can I do to find pieces of a right triangle? Pythagorean theorem. So this one says negative 5 squared plus y squared is 13 squared. So let's do the math there. It looks like y would be negative 12. Why is it negative? Because where it is, it's down, yeah. So the sine of alpha is negative 12/13. Negative 12/13. Now cosine beta, I'm going to do the same thing. X squared plus 2 squared equals 3 squared. So this will be negative root 5. So my cosine is x over r, adjacent over hypotenuse, negative root 5 over 3. So it looks like they have a common denominator, 39. This one's going to be 12 over 5 when I multiply. And this one's going to end up being a minus 10, because I have all these negatives in there. And there's your answer. Okay? All right, what else did you find that you have a question about? Yep, Avery?
Can you do 14A on this method?
The one we started the other day? Yeah, so I absolutely can. I want to say again, though, that all this has been videoed. The other crap hasn't. So I'm fine doing whatever, but I don't have answers to all that other stuff. I don't think. Maybe I do. Can't remember. Okay, so we literally should try to read this first of all. What is this saying? This is saying the angle whose sine is x over 3 is equal to the angle whose cosine is negative root 3 over 2. Remember, your inverse notation is an angle. Finding the angle. Now, since that's an x, I can't really do much with that. But this I can do. What is the angle whose cosine is negative root 3 over 2? Shouldn't need a calculator for this.
Oh, 5 pi over 6.
5 pi over 6? Not 7. Remember, where is the inverse cosine defined? Quadrants 1 and 2, the top half of the circle. So you figured out that the angle with a cosine of root 3 over 2 is pi over 6. But since it's negative, it's gotta be the quadrant 2 version of pi over 6, which is 5 pi over 6. So now the question says, the angle whose sine is x over 3 is equal to 5 pi over 6. Now I'm gonna say there's no answer to this problem. That's impossible. Because where does this have to be? Where's the inverse sine? Quadrant 1 or 4? Can a quadrant 1 or 4 equal 5 pi over 6? No, because that is quadrant 2. So that can't be. All right, what else?
On homework 312, can you do number 6?
Evaluate the secant of 13 pi over 12. Well, what's the first thing I have to do? Okay, yeah, so I know the problem is secant 13 pi over 12, but I'm gonna think of that, 13 pi over 12, yeah. I'm gonna think of that as a cosine. Because I know I'm going to have to do what with that 13 pi over 12?
Change it to 2 fractions next.
I gotta change it to 2 special fractions that are gonna add up to that. So someone was in here this morning having a hard time figuring out how to get 3 pi over 12. So we know what our special angles are, right? Pi over 6, pi over 4, pi over 3. 2 pi over 3, 3 pi over 4, and 5 pi over 6. Now let's just change all those into 12s. So this would be 2 12s, 3 12s, 4 12s. This would be 8 12s, 9 12s, 10 12s. Now somewhere in that combination, you should be able to find a pair that either add or subtract to 13. If not, you can keep going and do the same thing down here. But I think we got it in there. What would add up to 13?
Pi over 6 and pi over 4.
So 10 12ths and 3 12ths?
Yep.
Are there other combinations? Yeah, we talked about them. You only need one. So I'll go with that one. So that's the cosine of 5 pi over 6 plus pi over 4. Because this is 10 12ths and this is 3 12ths. And they're gonna add together to give you 13 12ths. One more time, there are other combinations. Find one, find the combination, we got it. Okay, what's our formula say for the cosine of a sum? Cosine of the first, cosine of the second, minus sine of the first, sine of the second. Now we're gonna do exactly what we did a minute ago. We're gonna start plugging in numbers. Only this time, the numbers aren't coming from triangles, the numbers are coming straight from the unit circle. So what is the cosine of 5 pi over 6? Right here, what's the cosine? Negative root 3 over 2. Oh, that's a pi over 4. All right, what's the cosine of pi over 4? Root 2 over 2, and so is the sine. What's the sine of 5 pi over 6? 1/2. So negative root 6 minus root 2 all over 4. Your common denominator is 4. Can't add these together, but we can build one fraction out of it. Okay? You'll get that same answer no matter what combination you use to get 13 pi over 12. You'll get that answer.
But does it need, like, how did you just get rid of the secant from the beginning?
Oh, I'm not done yet.
Oh, okay.
I'm not done yet. This is the cosine. So, yeah, I can't just forget that my original problem was a secant. So what will the secant be? 4 over negative root 6 minus root 2. Now, you gotta be careful because that simplifies. How does that simplify? Well, what would I do with that?
Rationalize.
And how would I rationalize it?
Multiply by negative root 6 plus root 2.
Multiply by what we call the conjugate, yep. So negative root 6 plus root 2.
Why are we subtracting?
Where? Here?
Yeah.
That's a formula. Gotta know your formula.
Even if it's added.
For cosine, yeah. For cosine is the opposite.
Okay.
Now, what happens when you FOIL out the bottom? What is negative root 6 times negative root 6? 6. These two are going to cancel because one of them will be positive, the other will be negative, right? And then I have negative root 2 times positive root 2, which is negative 2. So the denominator just works out to be 4, which will cancel with that 4 we had originally. And our answer is negative root 6 plus root 2. That is our final answer. Okay? All right, what else?
Can you do 3A on the 3.12? 3.12.
Number 3,
A.
A. All right, so 3.
Can you stop?
All right, so we got an angle in standard position, negative 5. So the angle looks like this. That's theta. And this is negative 5 and that's 12. So taking a clue from what we did earlier, what's my hypotenuse or my radius of this big circle here? 13. All right, so there's a picture. Now I'm finding the sine of 2 theta. What's my formula for the sine of 2 theta? 2 sine cosine. So then I'll just pull the numbers off my picture. So what's the sine of that angle? Y over R, so 12/13. And the cosine is negative 5/13. So when I multiply, I get negative 120 over 169.
I got that answer. I was just confused how I got a negative answer because I was just confused how I got a negative answer.
Okay, so remember, theta, angle theta is in quadrant 2, right? So theta is between pi over 2 and pi.
Yep.
You are dealing with 2 theta.
Oh.
So when you double that, 2 theta is between pi and 2 pi, which automatically means that sine's gonna be negative. Right? All right, who else? Who else has one we need to look at something somewhere? All right, I'm randomly then gonna finish this review sheet. So I'm going on that 382, 312, that big review sheet we started. I am going to problem 28. sure I have this whole worksheet done. I'm on 28, very good. I'm gonna do the last two problems on this worksheet. All right, so it says M has to equal P, so 2 plus root 3 cotangent equals 1. All right, so it looks like root 3 cotangent equals negative 1, and cotangent equals negative 1 over root 3. And we're between 0 and 1. Now, I've done this enough, you've done it enough. You're thinking of your unit circle. Doesn't this mean negative 1/2 over root 3 over 2? Those are the numbers from the circle. This is cotangent. I'm leaving it as cotangent because cotangent is x over y. So x is negative 1/2. Well, x is 1/2, y is root 3 over 2, and one of them's negative. Where can that happen? Where could that happen? That x is, what kind of angle has an x of 1/2 and a y of root 3 over 2? Pi over 3. So I got my pi over 3 angles. But it's not pi over 3 because one of them has to be negative. So it's gotta be this one or this one. So my answers are 2 pi over 3 and 5 pi over 3. Those are the two places where the cotangent is negative in that domain there. Okay? That okay with everybody? All right, name number 29. We want that to equal 2. Okay? So 5.1 plus 2.3 cosecant 0.4x minus 2 has to equal 2. Does everybody understand that's what the problem is saying? Okay, so let's go ahead and solve it. So 2.3 cosecant equals negative 3.1. Keep an eye on my arithmetic. So cosecant equals negative 31 over 23. I don't like having all those decimals around. It doesn't matter. If you want to do 3.1 over 2.3, that's totally fine. Totally fine. Doesn't matter one bit. But I don't do cosecants. My calculator doesn't do cosecants. So I'm going to change that to a sign. So if the cosecant is that, what's the sign? 23 over 31. One of those are negative, right? Negative 23 over 31. Okay, is everybody okay here? All right, now I want you just to stop a minute and think about, because it all fits together. It's exactly the same thing. Over here, I'm just in the process of erasing it. We knew the cotangent was a negative number. So we immediately knew our answers were going to be in these quadrants because that's where the cotangent is negative, right? So what do I know here? I know the sign is negative. So I automatically know my answers are going to be in quadrants 3 or 4. Agreed? Now, the next thing we did over here is figure out that the angle that has that fraction, we already took care of the negative, we put it in these quadrants, we looked at that fraction and said, okay, that angle's pi over 3, right? So you put your pi over 3's in the appropriate quadrants. So instead of drawing pi over 3, you drew 2 pi over 3. And 5 pi over 3, right? So what I'm gonna do now is I'm gonna figure out, I already took care of the negative, negative's done. I'm gonna figure out what kind of angle has that sign. So I'm going to second sign 23 divided by 31. And that angle is 0.836. It's not one of my special ones, it's not a pi over 3 or something, but it's 0.836 according to my calculator. Now I'm gonna figure out, okay, so what is the actual angle? Well, they're in standard position, so we're starting at 0 and working our way around to here. So how will I find out how big that pink angle is? Add pi. Or I just add pi, which is exactly what you did over here, only you subtracted it from pi, because of the point. So that angle, that thing is, oh wait, 3.978. So my pink angle, one of the answers to the question, forget this, the sine of that angle is this number. Well, what about the other one? How big is the other one? That would be this one right here. How will I find that one? 2 pi minus 0.836, which is exactly how you got 5 pi over 3. That's 2 pi minus pi over 3. We're doing the same thing. So that blue line is 5.447. Now this is where you gotta be careful. Those are the angles, so that's what goes right here. Well, that's not an X. If that had been an X, then those would be the answers. But it's not an X, it's that. So this equals 0.4x minus 2, and this equals 0.4x minus 2. The 0.4x minus 2, Enzo, you're hurting my self-esteem. The 0.4x minus 2 has nothing to do with anything until you get to the end, until you know what your angles are. You gotta find your angles first, and then solve for x. So 3.978 plus 2 divided by 0.4. Did you get 14.945? And then the other one, point, or no, 5.447 plus 2. 18.68, 618. Now, tell me about those answers. What do you think about those answers? Those answers, those x values, do not fit in your, in here. Because that's 6. Those are both too big. Now I'm doing a quick check here because I think there may be a workaround. I'm not sure. Those two don't work though. Those two answers for sure aren't going to be working. tricky problem. I thought there were answers, and there are answers. Can anybody think of a workaround for this problem? Anybody think? And so can you hand me on that pile right there? One of those, just one. Yeah.
Thank you.
That's what we're doing part of the time. Alex?
Just subtract 2 pi from each of the answers.
Ah, Alex says the reason that this isn't working out is because those answers, the pink and the blue, are pretty big angles. And so when I ended up adding to them and then dividing by a fraction, they got even bigger. So Alex says, what if instead of calling that pink angle 3.978, what if I called that pink angle another name? So it's like if you have pi over, let's say 5 pi over 7. Are there other names that you could call that angle?
Yeah.
How do you find those? Add or subtract 2 pi? So think about this for a second. If I added 2 pi to these, they would get even bigger. So maybe we should subtract 2 pi. Now, not from the end result, not from the x values. The sine of this angle has to be that. So that's one option. What would be another option? 3.978 minus 2 pi. So another pink option could be negative 2.305. Another pink option, negative 2.305. And what would be another blue option? Negative 0.8, oh, that one right there. Negative 0.836.
But that wouldn't work because it's still negative. Because it's under 0.
Okay,
Has to
but
be-
wait a second, wait a second. X has to be in there. Remember, these aren't X values, these are X values. These are those values. So 0.4x minus 2 has to equal negative 0.836. Is that gonna come out positive? It is.
Were you doing the
So
0.5
that
one?
one's gonna give us
Oh,
the
you're
answer.
doing
What?
Were you doing the one, the 0.54? The 0.5447?
No, I'm doing this one first, cause he wanted to rule that one out. Yeah, so that blue version
Oh,
of that,
okay, okay.
the
You're-
coterminal angle. for
We're doing
that.
the pink one doesn't work because it's negative. Because
The
it's
pink
negative.
one won't work because that answer is gonna come out, X is gonna come out negative. This one will work though, because when you solve that, you're gonna get a positive number that's less than 2 pi. That is tricky. That is tricky. Sometimes we have tricky ones. Okay, all right. What else? What else?
We do, just do B on, 3.12, 2B.
Homework?
Yeah, 3.12.
3.12 homework 2B. I know, there's a lot to keep track of.
What's the identity for tangent of twice the angle?
I would just put the sine over the cosine, you've already found those. Is tangent signed by the cosine? That's an identity. Yeah. Okay, so what's this? Cosine pi over 2, sine pi over 7. minus cosine pi over 7 sine pi over 2. Your job is to simplify that. That's a formula. It's one of your identities. Which one is it? Cosine sine minus cosine sine. That is the sine formula, right? Now, you need to be careful. This is a sine formula. You need to be really careful about the order though, because it's a subtraction and subtraction's not commutative. So the actual identity says sine of the first, cosine of the second, minus cosine of the first, sine of the second. This is what your identity says. Alright, so what is your alpha? Alpha is the angle that you take the sine of first. So no matter what the order is, these two are exactly the same. But you gotta recognize alpha is pi over 7. So this is the sine of alpha minus beta, which is going to be the sine of negative 5 pi over 14, which is negative sine 5 pi over 14. How do I know that? How do I get from here to here? What's the reason I can do that? Sine is odd. And what does it mean to be odd? Put in a negative, get out a negative. Right? Okay, who else? If that were a plus, I wouldn't have to worry about it, but since it's a minus, I do have to worry about it. Declan?
I was just wondering for that, would it be wrong if you didn't simplify from the,
From here? No.
yeah, like if you left it at sine pi over 7 minus pi over 2?
Yeah, that would be wrong.
Okay.
Okay, what else? Mary Kate?
Could you do 3B on the same homework on 3.12?
Do what now?
The 3B on the same homework.
Same homework. 3B, find the cosine. Oh, shoot, I erased my picture. You still have it though, if you wrote it down. So looking at the two pictures, I drew a picture of alpha and I drew a picture of beta. Oh no, I don't have that, I just have one. I just have theta. I can do that. It was in quadrant 2, negative 5, 12, 13. Alright, so there's theta. Alright, and I want the cosine of 2 theta. Well, I have a choice here, it makes no difference which formula you use, which identity, which one. Doesn't matter, they'll all give you the same answer. Okay, so cosine squared minus sine squared. Alright, so looking at my picture, the cosine is negative 5/13. And the sine is 12/13. So this is gonna give me 25 1/69. That's gonna give me 144 1/69. So subtracting is gonna give me negative 119 1/69. Okay, I just got done telling him this. What is tangent? By definition, what is tangent? What else is it? Yes, it's y over x. What else is it? Sine over cosine. Earlier, I found the sine of 2 theta. I just found the cosine of 2 theta. Put sine over cosine, and that's going to be your tangent. Okay? Yep, don't make it hard. It's that easy. All right, what else have we got? else do we have? All right, random question. I'm just pulling off the sheet here. Oops. What's the period of that? What is the period of that function? I heard 4, I heard pi. Okay, so on our scale of 1 to 10 difficulty, this is like a 0.003. How do you find the period of anything? You take its standard period and divide it by that number. What is the period of a tangent? Pi. So you're gonna take pi and divide it by pi over 4, which is timesing it by 4 over pi. So whoever said 4 over here was right. Period is 4. All right, let's try another. Is he asleep again?
Yeah, he's passed out.
All right, so here is an equation that gives the distance above the ground after t minutes. So t is minutes and y is height. That's what this formula does, okay? The question is, what is the maximum height? What is the maximum height? 7? Yeah, because your midline's 4 and your amplitude is 3, so your highest point is going to be 7. All right, here's one. This one's going to take some effort. So cosine x equals sine 2x, and we are solving between 0 and 2 pi inclusive. All right, so here we go. Write it down, figure it out. What are you going to do first?
Can you divide sine 2x over?
You need to subtract, I hope.
Oh, yeah.
Boys and girls, we aren't going to divide.
You can't divide by a variable.
Exactly.
Brain rot.
I'm just when someone says
So what are we gonna do?
You do the identity
What
thing.
did you say? For what? Exactly. So Owen Pack has looked at the problem and said, Mrs. Ford, we cannot solve this when it has a plain x and a 2x. You can't do it. So what are we gonna do? The only thing we can do is change this, because we have a formula for that. What is the identity for sine 2x? 2 sine cosine. Now, I've got all x's at least, but now I've got sines and cosines. What a mess. Keep going. What can I do now? Subtract the cosine over. Because we are under no circumstances going to divide. No. Factor out a cosine. Oh, we got 2 equal zeros in there. All right, now what? Cosine equals 0, or sine equals 1/2. All right, where does the cosine equal 0? Yep, right here and here, right? So you've got pi over 2 and 3 pi over 2. Where does the sign equal 1/2? Pi over 6 and pi over 6. There we go. Good job. Alright, let's try this. What is the first vertical asymptote to the right of the origin for tan x? So your regular tangent function, what is the first vertical asymptote to the right of the origin? Pi over 2. Pi over 2. Exactly. All right, how about this? Simplify that. What does that equal? Someone tell me before I have a stroke. 5, absolutely. Because if you factor out the 5, you have cosine squared plus sine squared, which you all know is 1. So we have 5 times 1, that equals 5. All right, let's come back to this equation right here. Okay? So, like, you got a Ferris wheel going around, and this is minutes, and the height. Okay, so here's the question. How long does it take to make a full revolution? How long does it take this Ferris wheel? There's his equation. How long does it take the Ferris wheel to make a full revolution? Don't overthink it. Wouldn't a full revolution be a period? Aren't I just asking you what the period of that is? And how do you find period? Cosine. So it's 2 pi divided by pi. So how long does it take it? 2 minutes. 2 minutes. Go all the way around. All right. How about this? What is this? Right there, what's that equal? Pi over 6? Negative pi over 6. Absolutely negative pi over 6. Remember the principal values for the sign, inverse sign, are between negative pi over 2 and pi over 2. So negative pi over 6. How about this one? We didn't memorize rules for the secant, but we did memorize rules for the cosine. So this would say the cosine is negative 1/2.
Yeah, horizontal in a 4
What's the answer to that one? I heard somebody say it. 2 pi over 3. Absolutely. Because for the cosine, your answers have to be up here. Very, very good. Remember, we don't have time to do another one, but remember your inequalities when you start shading. And let's say you shaded everything. This is 11 pi over 6, and this is pi over 6, and you shaded all of this. And then you also shaded another part of the problem. You shaded from, let's say 5 pi over 3, pi over 3, and you shaded this part of the problem. Be careful when you write your answer. Clearly, this is the overlap, right? But when you write our answer, remember we have to start with 0. So we'll do 0 to pi over 6. And then 11 pi over 6 to 2 pi. And if, I don't have any direction, normally that's open, but once in a while that will be closed, and if you want to include that 2 pi, it will work. Okay, remember all that? All right, Wednesday we take our quiz over 3/8 to 3/12. Sleep through class, don't stress about
Oh, no, this test I'm stressed about.
it. Sleep through class.
It's everything else I'm not stressed about.